Hello, this is the last section for test 3. So we have quadratic functions, polynomial functions, rational functions, and now we're doing systems of nonlinear equations. So hopefully what you do is you recognize some of the shapes, but basically what that first equation is, it's some kind of parabola, quadratic function, and then the second equation is just some line. And so what could happen is you could end up with 2 points in common, or you could have it where it completely misses and has no points in common, or you could have it where it's going to touch at one particular location. And so you have 1 point in common. So you could have one answer, no answers, or 2 answers is what could happen. Oh no! Crap. Alright, well, you're going to laugh at this, but I just did 4 more slides and forgot to turn the darn thing back on. So we're just going to go ahead and start over again on slide 2. So we're going to substitute, not an eraser, we're going to substitute this in place of the y that you see right here. And I'm going to have x plus 2 quantity squared is equal to negative 2x minus 4. And just for review purposes from previous chapters, this is a quadratic that is shifted to the left 2. And this is going to be some line that's going to do something like this. And I might be missing the actual locations, but that's why we're going to go ahead and graph so we can see exactly what's, or not graph, but solve. And we're solving this by substitution. That's the technique we're going to use most of the time when it comes to systems of nonlinear equations. So when you square the binomial, don't forget that you get a trinomial. Don't kill any puppies. And then I'm going to add 2x plus 4 to both sides. So x squared plus 6x plus 8. And we're going to be able to factor that. So what factors of 8 add up to a positive 6? It's going to be x plus 4 and x plus 2, because 4 times 2 is 8, and 4 plus 2 is 6. So I get 2 possible answers for x. I get a negative 4 and a negative 2. Alright, so what I know is the x-coordinate is a negative 4 and a negative 2, and I've got to find the y-coordinate. So it really doesn't matter which one we use equation-wise to solve. I'm going to go ahead and use the top equation because I used the bottom equation when I recorded it before. So I'm going to be different, even though you never saw me do it that way. Alright, so this is a negative 2 squared. We're going to get a positive 4 for that one. And we do a different color. If I plug in a negative 2 into this, we're going to get a 0 squared or a 0. So I missed my point. It should have hit this point right here. My line should be more over here. Oh well, you don't have to graph it. It's just something that I would hope that someday, if I see in a calculus class, that you would recognize some of the shapes based upon the equation. So let's do the next one again. So this equation, you may not realize, is something that you're familiar with, because if you divide by x, you get y is equal to 4 over an x. And that's just like the shapes that we just talked about in section, I think it's 3.5 with rational functions. So it's a little bit different that you got a 4 there instead of a 1, but it's really not that much different. And if you were to do that line, y equal x, well, that's a slope of 1 and a y-intercept at the origin. So our points are going to be pretty much identical points based upon this equation right here. So I want to do something different. I'm going to substitute, this time, I'm going to substitute the y in place of the x right there. So I'll have y times y is equal to 4, y squared is equal to 4. Do the square root property, I would have y is equal to plus or minus 2, because I know I'm supposed to have two answers by the fundamental theorem of algebra. So I know I've got a 2 here and a negative 2 here, and I've got to figure out what in the world my x is. But y is equal to x, so I can plug in the 2 here, and that's going to give me a 2. And if I plug in a negative 2 in place of the y, that's going to give me a negative 2. So you can tell by our beautiful picture that this point and this point are the ones that we're talking about in quadrant 1 and quadrant 3. So there's the third example. Alright, this one is a little bit different in the fact that you're going to have a quadratic shape that is shifted up 2 units. And then this one is going to be a quadratic shape that's shifted up 1 unit with a different shape because of the coefficient. So it's going to have 2 points in common probably. So we're going to go ahead and just do a substitution. I'm going to substitute that in place of the y right there. So I have 2x squared plus 1 is equal to x squared plus 2. So I'm going to go ahead and subtract x squared from both sides. And subtract 1 from both sides. So I get x squared is equal to a 1. And I'm going to take the square root of both sides. Stop it. So I'll get x is equal to plus or minus a 1. So again, we have the x coordinates, we got to find the y coordinates. So when I find the y coordinates, I'll just use that top equation and I'll have 1 squared plus 2 is a 3. And if I use the negative 1, it's not going to be any different. It's going to also be a 3. That has to do with the symmetry involved with those two equations being symmetric with respect to the y-axis. Again, something from chapter 2 that I hope that you remember. Now we're going to be where I left off before when I didn't record it. So notice I haven't paused this time. So I need to solve for y or x and use it for substitution. I think the easiest thing would be to add x to both sides, and I'm going to substitute that in place of the y right here once I finish my arrow. So after I do the substitution, I'll have x plus 1 is equal to x squared minus 4x plus a 5. Subtract x, subtract 1 from both sides. Whoops, I get 0 on the left side. I miss having you watch me make silly mistakes, fixing them for me. So we'll just have to find them as we go. And this is going to be factorable. This is going to be x minus a 4 times x minus a 1. So I get two possibilities for x. It's going to be a 4 and a 1. And so I need to substitute the 4 into either of those equations. I think I'm going to use that equation. So 4 plus a 1 is going to give me a 5, so I'll have the point 4, 5. And if I put a 1 in place of the x, I'll have a 2. So the other point is going to be 1, 2. So here's an answer, and here's an answer for the two intersection points. And last but not least, so this is definitely not as long as the other one. And the good news here is I can do a direct substitution. I can put that in place. I don't have to solve anything. I'm going to set it equal to 0, so I'll have a negative x minus 2. And I can factor that into x minus 2 times x plus a 1. So my x's are going to be 2 and a negative 1. which means then I know this, and I have to figure out what the y values are for this. So let's just use y equals x squared. So if I put a 2 in there, that's going to be a 4. If I put a 1 in there, a negative 1 in there, that's just going to be a 1. So here are 2 points in common. So what do you need to remember? Well, you need to remember substitution. And then you got to remember that you're only finding the x or the y, and you're looking actually for both the x and the y for 2 different points. That's typically the kind of equation that I ask for, where you get these 2 answers when I ask you to do the one question on your test. So, much shorter than the last one, and this completes, I think, the last topic that we'll have for test 3. So we just need to study and get ready for the test when the time comes.